All right, growth mindset, math, maniac, math side at Panthers. All right, I encourage you to try this problem and then check back and see how you did. We'll go over it together. All right, I'm going to highlight some things here. Okay, I highlighted this kind of funky because I see that less than, and that's like a big red flag to me that I even make it red, and this is supposed to be red. Let's try that again. A big red flag. You know what? Let's make it a red flag. Here we go. There we go. It's a big red flag to me. It's saying, yeah, this is going to be something a little bit different. It means it's a switch. It's a switch. If you say less than, if I am 10 and you are 3 less than me, you are 7. So really, if I am 10 and you are 3 less than me, right? You are 3 less than me. But me, I am 10. So let's just slide that 10 right here. That's me. So why I just put the number in there. Here we go. 3 less than 10. Oops. A little technical thing going on here. I lost my n somehow. There it goes. What's 3 less than 10? Remember, I am 10. You are 3 less than me. That makes you 7, right? 7. So 3 less than 10 is 7. So would you write 3 minus 10 equals 7? No. We would switch them around. So I'm going to color code these the same way we color coded up top. I'll make the 3 yellow, and that less than, my big red flag, less than, because that's going to tell me, it's really my switch words, I guess. In this case, it's not always a switch word, but in this case it is. So don't always think, oh, that's greater than or less than, we got to switch. No, not in that case. That's a different context. Within this context, which I think eventually you'll get the hang of, it means switch. You'll be able to identify when to switch and when not to switch. And this is a time to switch. 3 less than 10 equals 7. Let's just look at our 3 less than 10. What did we do? In order to do this correctly, we got to switch these. We got to put the 10 first. We got to do 10 minus 3 to get 7. So we're really putting the 10 first, and then we're still keeping this less than meaning minus, but then we're putting the 3 here. That makes more sense. We're going to do the same thing up here. We're going to take our yellow and green and switch them. We switched our yellow and green down here. We're going to switch our yellow and green up here. Okay, so 3 and the 5. Oh, let's go black. 3 and the 5 times a number, we switched. I switched my yellow with my green. I put my 3 here, and I put my 5 times a number here, which is 5 times a number. And for number, we're using x. X is for the variable, so that's why I chose to put x here. That, I believe, is it. Is equal. I'm going to clean this up. This is getting a little messy up here. So many arrows, every which way but loose. We'll keep the yellow here, though. That's nice. So now, let's look at what's left. We have is 12, and that is the answer. Okay, I already started color coding here. Susie buys a salad for $5.12. And then she's given $14.88 as change. They want to know how much money did she have to begin with. Well, that's not what they want to know. They want to know what the equation is. They want to know what's the equation that represents what she would have. Which equation represents this situation? If X is the amount of money she had before. So she has some money, she spends some money, and then she gets some change back. So we'll keep the X the same. That's how much money she has. Then she spends some of it. We got to subtract some of that money. And how much does she spend? $5.12. So we'll put $5.12 in here. $5.12. That's how much she spends. Then she's given some money back afterwards. This is how much change she's given. $14.88. It's a great year. Yeah, I was alive that year. Yeah, I'm a little old. You do the math. See if I'm joking or not, huh? You think I'm joking? Do the math. All right. Where were we? Oh, yeah. So she gets this much money back, right? So if she starts with this, subtracts, I think that's it. That's all there is to it, right? I'll color code this. That's how much she spent. That's how much she got back. X is what she had to start with. So voila, it's B. Yeah, very nice. Algebra. It's algebra, bro. Bruh. Algebra, bruh. There we go. Okay, so I already did some color coding. Eva worked 2.5 hours more than Waylon. So this is what Eva worked, all of this stuff inside of here. Together, they worked a total of 22 hours. You put them together, Eva and Waylon, you get 22. So this is Eva plus Waylon equals 22. Waylon worked H hours. So wherever we see Waylon, we're going to put an H there. So let's see how this can make sense. So what do they want to know? So if we put Eva and Waylon together, we're going to get 22. Eva plus Waylon's hours equals 22 hours. Well, Eva, let's do her first. She worked 2.5 hours more than Waylon. So she did what Waylon did plus 2.5 plus Waylon. Oh my gosh, so this is just this E, okay? This is just this E. This comes from, let's see, we'll circle it in purple. The 2.5 comes from here, more than Waylon. And then the more than is the add that goes here. And then Waylon goes here. And I know we said we're going to put H in for Waylon. We're going to do that. Maybe we should do that last. Let's see. Okay, this is just this E. So I'm going to color code this a new color so hopefully it won't get confused. We'll go with orange. We haven't used that. So Eva is all of this, which matches all of this, right? 2.5 hours plus Waylon, whatever he worked. Then we still got Waylon. We got to add him. We already added him. No, that's part of Eva's. We got to put Waylon on his own thing. His blue. He's blue. We'll keep him blue because he's just over here lonesome. So we're just going to put plus W. This time we're talking about this W right here. See? Right here. And that's the plus that goes with it right there. Yeah, we'll just do it like that. Okay, so now let's put all of the W's, we're going to put H's. All right, so I'm going to clean this up. Be right back. Okay, I hope this is cleaned up a bit. So Eva is originally yellow, right? But we kind of turned her into orange. So let's just change her to orange here too, right here. So Eva's orange now, Waylon's blue. All right, so now, well, what about this? You might be saying, Mr. Hoffman, how come this Waylon part isn't blue? Because that's part of Eva's work. All right, that's part of Eva's work. Okay. So let's see, what did I do here? There we go. So we're going to replace all the W's with an H because it says Waylon worked H hours. So everything there's a W, we're going to make that H. So we have 2.5 plus H plus, here's this plus, we're in the blue now, H. So this 2.5 plus H came from here, and this plus H over here came from here. And that should be it. Do we have that over there? I'm trying to find it. I see it, but it's not written the same. Oh, and I almost forgot. This is an equation. I forgot to do this. I was going to say we, but it's just me, isn't it? I'm kind of working by myself here. Still got to put equals 22. That's going to help. Okay. So we're looking for something that matches this. Have you guys found it yet? I think I saw something that, it's definitely not this one. That's 2.4. I thought I saw another, no, that's the only 2.4 one. Okay. They're all plus 22, so it's not A. H plus 2.5 plus H. I think it could be this one, maybe? They just switched the order on us. They kind of put parentheses around here, and then they switch the order. But order doesn't matter, because that's the commutative property when you add. This one's some subtractions. You can't do that one. This one doesn't have the 2.5 in it. Oh my gosh, that makes it easy. It's this one. Take a break. Okay, is your head exploding yet? Mine has, but I picked up all the pieces, I put them back in, I'm ready to try again. Here we go, like Humpty Dumpty said on the wall. But this Humpty Dumpty brain had a great fall and got put back together again, and it's even better than it was before. Let's do it. So, color coding here in the basketball game. Ray scored 2 less than 5 times the number of points that Ben scored. Wow, we're getting really crazy here. That's 18. So we know how much Ray scored. We just found out how many did Ben score. Ray was 18. How much did Ben score based on the information we have? It's like a mystery. We're going to solve it. We're going to put together the clues. We're going to find out, kind of, sort of. Well, how would we solve it? That's what they want to know. They're just asking us to write the equation that represents this problem. So I could say Ray scored 18. That's an important piece of information, right? R equals 18. Let's just move this over to the side for a moment. What else do we know? We also know Ray scores 2 less than 5 times the number of points Ben scores. So Ray scores also equals 2 less than 5 times. Oh, I forgot, you can't use X for times anymore. We're like in 6th grade, now we start using dots. Times the number, and they say whenever you see number, they're saying let B be the number of points for Ben. So that's Ben, the number of points Ben scores. Oh, that's convenient. That's the number of points Ben scores. Okay, so, here's the thing with this, remember this less than? That's my red flag. In this case, I'll just put a little flagpole like this. Less than, that means we got to switch whatever is in blue with the yellow. So let's color code what we have down here so we can switch what we need to. So what's in blue is, trying to get my blue marker, highlighter, is 2. We got to switch with what's in yellow, which is 5 times the number that Ben has. All right, so let's switch it. Here we go. All right, can you see what we got to do now? There's one more step that we have to do. We have to, so do you see what I see? Do you see what I see? Right here, R. We're doing R is green. What do we know about R? What does R equal? There it is, 18. So we're going to rewrite this. Instead of an R, we're going to put 18 here, right? Let's just erase that and put 18, because R is 18. That's 18. We can still color code it green. Now we can use this to figure out what Ben scored. Do you know what Ben scored? I mean, this is what let's see, can we find the answer? They don't have it written this way. They put the 18 last. See, the 18s are always over here in our choices. So let's move the 18 here too. We can do that. We're allowed to do that. We don't have to keep it here. If I can grab onto it, right, with my pen tool. I think I might use the mouse on this one. Here we go. Oh, that's so much better. And we got to move the equal sign too. Now, does this look like any of our answer choices? Let's see. 5. Oh, I see what they're doing. They're not putting the dot in there. They're not doing that. So we'll take the dot out. We'll be sophisticated and elegant, but simple. So here they're just writing 5b, and they're using lowercase letters. So I'll just do that. Minus 2 equals 18. So now do we see this over there anywhere? Yeah, right here it is. There's the ticket. He shoots, he scores. Or she shoots, she scores. Or people shoot and people score. Persons. The person shoots, the person scores. All right, this is the last one? Oh yeah, last one. Oh, goody. Be right back. Oh, look at all these beautiful colors. I love when color and math come together. Uh, Color by numbers, you ever done that? This is kind of like that. Oh, I missed, speaking of which, I just found a number that I missed. Let's get it right away. It's this 6 right here. So all I did is I rewrote this problem because there's a hidden multiplication sign. See this thing here is this is really 6 times x plus 3. So I rewrote it over here. 6 times, I remember times, and then we have x plus 3. Or do we do the x plus 3 first and then I'm not sure. Let's see what it says. Look at A. The sum of 3 and 6. Wait a minute. The sum of 3 and 6. That means you're adding 3 plus 6? Is that what we're doing? I don't see 3 plus 6. No, we're doing x plus 3. Right away, I can tell that's not it. 3 plus 3 times a number. I don't even see a 6 in here. Where's my yellow? Did you guys catch that? They tried to get a fast one on it, so it's not that one. Now these two both have 6s. They both have times. Okay. What do they have? 6 times some number. Oh, wait a minute. 6 times some number? That could be true, because we are doing 6 times some number. Plus 3. So it could be this one. This one is a maybe. I'm a little confused. Let's look at D. See if D is a little more clear. Okay, 6 times the sum of a number and 3. Oh, the sum of a number and 3. Isn't that what we have here? Right here, the sum of a number and 3. Yeah, and then we're multiplying it by that 6, like that. Yeah, see, this could work. C almost works, but it doesn't quite work. Because if we did 6 times a number and then added 6 times 3, because this would be, if we try to work with C, it would look like this. Everybody would look like 6 times a number plus 6 times 3 equals 42. And it's not saying that. It just says plus 3, not 6 times 3. It's missing that 6 times 3 part right here. So that's not it. It's got to be D. Yay! We're done. Bye, bye, bye. A person who never made a mistake, never tried anything new. That Albert Einstein, I think he knew a couple of things. At least a couple, if not more. I heard about him. All right. Bye, everyone.